Hello, this is the United Learning Walking Talking mock for mathematics. This is the November 21 paper, paper 2, which is the calculated content. This section goes through the crossover questions, so that's for both higher tier and for foundation. So ahead of using these examinations, we need to make sure that we are familiar with the GCSE provided formula page, or the exam aids as they're referred to, which is on yellow paper on the video in front of you. There's a separate one for foundation, and here is the higher tier exam aid for higher tier. As and where I've needed to use these sheets throughout the course of the modelling of the questions, I'll indicate that by showing the specific formulas that I've highlighted and taken off the sheet when working through the questions. So this is question 1 for higher tier and question 21 for foundation, and the question asks us to write down the inequality shown on this number line. So in order to work through this, we know that the circle is hollow, which means that the inequality is a strict inequality, i.e. it's not coloured in, so it's not or equal to, and we know that it starts at -1 and x can represent any value which is greater than -1. On the number line below, we need to show the inequality. Y is greater than or equal to -3, but less than 4. So we know that these are the numbers we're going to use. The first section is or equal to, so that means that is a solid circle. So I make sure that I colour in the circle at -3 because it can equal this value. And it goes up to 4. This is not or equal to, so I'm going to leave that circle hollow, and then I'm going to connect the two. Question 2 on higher tier and question 22 on foundation asks us to find the highest common factor of 60 and 84. So the way I'm going to do this is I'm going to set it out using prime factor form. This is probably the way that most of you have been taught how to do this. So I'm going to do the prime factors of 60. So 6 times 10 makes 60. 6 is not a prime number, so I'm going to split that up, and that's 2 times 3. These are primes, so I can stop at the end of these branches. 10 is 2 times 5. Again, both of these are prime numbers, so I can stop. So I know that 60 is 2 times 2 times 3 times 5. I'm going to repeat that process for 84 and say 84. Again, I'm going to split it up. I imagine most students will start and say that is 2 and 42. 2 is a prime number, so I can circle this. 42 is 2 and 21. 2 is a prime number, so I can circle that. And 21 is 3 times 7. Obviously, there's different starting values that I could have used to split up 84. I might have used 12 times 7. I might have used 6 times 14. Either way, I should finish with the products of primes the same at the end. So 84 is 2 times 2 times 3 times 7. And now I'm going to identify the highest common factor. What's common to both values? Well, the highest common factor is 2 times 2 times 3. I can't use the 5 or the 7 because that's not common to both, which gives us the answer of 12. You may have done this using Venn diagrams and know that the highest common factor is the intersection. So if this is 60 and this is 84, I'd have 2, 2 and a 3, and then I'd have a 5 in the only section of the 60, and 2 times 2 times 3 times 7 would be the only section of the 84. So part B asks for the lowest common multiple of 24 and 40. We might have done this through listings of just listing the repeated factors of 24 and 40, which might be a strategy to use here given the fact that it's a calculator paper. However, as that's not the case in this instance, I'm going to use prime factor form and then represent it in Venn diagrams. As was the case in part A, do remember that as this is a calculator paper, you could just generate the prime factor forms by using the fact button on a calculator, and then you could just check straight away that you'd got your prime factor trees correct, or indeed you could just instantly press it and get those immediately. So 24 is 3 times 8, and then 8 splits up to 2 and 4, which is 2 and 2. So 24 as a product of its primes is 2 times 2 times 2 times 3. 40 is 5 times 8, and 8 is 2 and 4, and then 2 and 2. So we know that 40 is 2 times 2 times 2 times 5. If you're used to doing this in Venn diagrams, then I'd have the 3 2's common to the middle, even though I've just written number 3 there. That would be 2 times 2 times 2 times 3. This would be 2 times 2 times 2 times 5. Just make that a tiny bit neater. So the lowest common multiple is the product of all the values inside the circles, which in this case is the highest common factor, 8 times all remaining factors. Alternatively, I could just do 24 times by 5. However you do this, so this approach, I'm going to say it's the highest common factor multiplied by all remaining factors, which gives me an answer of 120. Obviously this is on a calculator paper, so we're able to do it there. We could alternatively just do listings, given the fact list our multiples of 24 and list our multiples of 40, given it's a calculator paper, and then identify which is the first one that is common to both. Obviously, if the numbers are a bit bigger than that, it doesn't give us a clear strategy to be able to access that question, which is why I've done it using prime factor form to get us there, as is most common on the mark schemes. Looking at question 3, we're told that Sam drives his car on a journey, and here is the travel for the graph for the first 15 minutes of his journey. Work out the speed in kilometers per hour for the first 15 minutes of his journey in kilometers per hour. Okay, so reading off the graph, I can see that Sam travels 20 kilometers in 15 minutes. So I'm going to do this by scaling. So instead of converting minutes, 15 minutes is 0.25 hours, and then looking to do a speed distance time calculation, I want to know how far he travels in an hour. So that's 60 minutes. So proportionally, I understand that I've multiplied this by 4. So I'm going to multiply this by 4, which means he'll go 80 kilometers in 60 minutes, which is my speed, which is 80 kilometers per hour. At 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. So these are the key bits of information, and I need to draw this on the travel graph. So the first situation is I'm here at 10:15, and from 10:15 through to, well, each one of these squares represents, or these blocks represents 5 minutes. So through to there at 10:25, I'm going to be stationary. I'm just going to switch colour so you can see which section of the graph I'm now drawing. So excuse if these lines are not quite as neat as yours, please use a ruler. I'm going to say, right, well, horizontally, he's stationary for 10 minutes. Now 20 minutes at a speed of 75 kilometers an hour. Well, how far am I going to go? There's 75 kilometers in 60 minutes. Well, if I want that to be 20 minutes, I've divided this by 3. So I'm going to do the same with my 75, which means this is 25 kilometers in 20 minutes. So I know that I'm currently here. Oh, part of my graph's disappeared. Fortunate. I'm here up to there, it's 20, so I'm going to go another 25 kilometers. I've currently traveled 20 kilometers, so I need to go in 20 minutes. So if that's from 10:25 through to 10:45, and I need to increase from here, 20 kilometers up to here, at 45, in which case from 10:25 through to 10:45 would be how to complete the graph for Sam's travel journey. Looking at question 4, we need to complete the table of values for y equals x squared minus 2x plus 2. We have a table with 3 values already in it and 4 values to come. So this is a separate sectioned question. There's 2 marks for part A, part B and part C. We need to make sure we draw this. Now remember, this is a calculator paper, so I could have used my calculator in question 2, as I could have done in, for any of the questions, but question 2 was probably the first time that I really should have considered whether I needed the calculator or not. But then now I'm definitely going to make sure that I have the calculator here, making sure that I'm thinking about the most effective way to use this as we work through. Okay, so all of these things you would be checking, you would type into your calculator. I'm going to write on screen how I would calculate each one. So I know that I'm going to substitute. First of all, I'm going to work it out starting with number 1. I'm going to just work through the positive values first. So y equals 1 squared minus 2 times 1 plus 2. And then that's exactly what I type into the calculator. 1 squared is 1 minus 2 plus 2 will just give me 1. So I know that 1 would be in this value here within the table. Then I'm going to substitute in the value for 2. So what happens when it's 2? So 2 squared minus 2 times 2 plus 2. That will give me 4 minus 4 plus 2, which will give me a value of 2. The value for 5 is already there. The value when x equals 3 gives us y equals 5. That's already been worked out for us. I also need to work out what happens when x is 4. 4 squared minus 2 times 4. And then add the 2. Again, I'm going to type this into a calculator. 4 squared is 16 minus 8 gives us 8 plus the 2 gives us 10. But you're going to type that in, including the brackets, exactly as I've written. So the first major problem with regards using the table of values is going to come with this last value of when x is the negative. If you don't tell the calculator to square the negative, then it'll get it wrong. So I need to make sure that I'm substituting into the brackets all -1. So I do -1 all squared minus 2 multiplied by -1. Add the 2. -1 squared is +1. -2 times -1 is +2. So I get 1 plus 2 plus 2, which gives me 5. And so 5 goes into this value here. Please make sure that you're checking those in the calculator. If you get all 3 values right, you'll get 2 marks. If you get 2 or 3 values in the table correct, you will still get 1 mark. So that's why I've worked through the positive ones first, just to make sure I'm happy with the concept of substitution. Okay, moving on to question B, I'm now going to plot my values. So I need to plot all 5 of these coordinates correctly. So when x equals 4, y is 10. When x equals 3, y is 5. When x equals 2, y is equal to 2. When x equals 1, y is equal to 1. X equals 0, y is equal to 2. X equals negative 1, y is equal to 5. And x equals negative 2, then y is equal to 10. Okay, so we should know that quadratic graphs are symmetrical. It should produce a U shape or an N shape. It's negative. I can see my values are symmetrical. I'm happy with this looks. Now I need to make sure that I draw my graph, connecting my points to get the second mark in part B. Should be a smooth U-shaped curve, which means you don't use a ruler. The graph is a parabola. It should be one continuous curve, plotting through your points. Obviously, I'm producing mine on a computer screen, which won't be as neat as yours, which will look like this. Okay, and then that takes us on to part C. So in part C, I need to use the graph to find the estimates for where the quadratic is equal to 4. So what I need to do is identify, use a graph to find the solutions, plural, telling me there's more than one answer. Where does this graph equal 4? Well, y equals 4 is a horizontal line. I draw a line across at 4, slightly better than that one. I'll just read. And say, where does the graph equal to 4? So I have a value here. Again, please use your rulers as you do this. Just draw a horizontal line at 4, see where it intersects the curve, and come straight down. See where it intersects the curve, come straight down, and you should see that there's 2 separate points. So I have a value, my first value is at negative 0.7, and the second value is at 2.7. So this question is about right angled triangles. And so the first thing that I need to be comfortable with from my revision is right angled triangles. I'm expecting it to be either Pythagoras or trigonometry. So I'm going to make sure I have the formula page open in front of me. I'm looking at this key piece of information. So the shape below is made from 2 of these triangles. I have to work out the perimeter of the shaded shape. So in looking at the shaded shape, there are 2 measurements that I don't know. First, being this diagonal line there that I've just highlighted in yellow, and second being just this extra little section here in order to work out the perimeter. So the first one is to work out what the yellow diagonal line is. Well, that's the hypotenuse of one of these shapes. So the first thing I want to be able to work out is what is the perimeter, is what's the hypotenuse of one side. Apologies, I've just been writing in white. So what's the perimeter? So I'm going to use Pythagoras' theorem, which is a squared plus b squared equals c squared. I know that I'm giving the final answer to 3 significant figures. So in my calculations, I'm going to work to more than that throughout the course of it, and then I'm going to round my answer at the end. So I know that C is the hypotenuse, so 8 squared plus 10 squared equals C squared. So I have C squared is 164, and I'm going to do the square root of 164 to work out my value for C. Once I've worked this out, I know that I then need to use this in the second section to calculate the little green bit. So the square root of 164, I'm going to work to 3 decimal places for the time being, so I've got more information than I need. So this is 12.806. To work out this small green section, that is the distance of a hypotenuse, which is 12.806 minus a base of one of the triangles, which is 10. So 12.806 minus 10 is 2.806, and so then the total perimeter if I go round the shape is, let's just have a quick look on the diagram and say what have I got as total perimeter. So total perimeter is, if I work across the bottom, I'll have 10 plus 8 plus another 8 plus 1 hypotenuse plus an extra little green section. So I had 10 across the bottom, 8 up the side, a second 8, then 1 full hypotenuse, and then 1 additional little section which was initially highlighted in green. So we do 10 plus 8 plus 8 plus 12.0 plus, 12.8 plus 2.8 gives us an answer of 41.612, which to 3 significant figures is 41.6. The measurements were in millimeters to start with, they're still in millimeters now, so there's no extra unit conversion required. Looking at question 6, so we have ABC being another right angled triangle, and we've just had a right angled triangle in our previous question, but as with right angled triangles, the previous question was completely about the lengths, nothing to do with the angles, which is why we use Pythagoras. Here we've got a side and an angle, so we're aware that we're using Pythagoras or trigonometry. I'm going to go to these formula and make sure that I'm comfortable with them. I have to work out the length of BC in this triangle, which I'm going to label over here. Call that side that I don't know X for the time being. Now in relation to the angle of 56 degrees, X is the opposite side and 12 is the adjacent side. Side AB is the hypotenuse, but for this question I don't need that information. So if I've got O and A, either using the formula page or using my mathematical knowledge and revision, I know that I need to use tan. Identifying that tan is the correct ratio is not enough to get us a mark. We have to put that correctly to find BC. So I know that tan of the angle is equal to the opposite side divided by adjacent. So in this case, that's tan 56 is equal to x over 12. I want to make x the subject, so I'm going to multiply both sides by 12. So I have 12 tan 56 equals x. And now I type that in, making sure my calculator is in degrees. I've got 12 tan 56, which gives me the answer of 17.790731, etc. Question asks me to give it to 1 decimal place, so I look here at the second decimal place. It is a 9, which means I round this up, so my answer is 17.8 centimeters. So moving on to part B. Again, second 2-mark question, asking me to work out the size of the angle. A right angle triangle containing sides and angles. We know it is a trigonometry question. Identify what the missing sides are. In this case, the 15 is next to the angle, so that's an A. The 18 is a hypotenuse of the triangle. Side PQ is opposite, but as I said, for this question, we don't need that information. So I'm concentrating on A and H. So I know I'm using cosine. That's not enough to get your mark. We need to set up the equation correctly. So cosine of the angle is adjacent over hypotenuse. So for this question, that's cos of the angle is 15 over 18. I need to find the angle, so I need to use inverse cosine. Now I can type that into my calculator, and if we do inverse cosine of 15 over 18, this gives me x is 33.55730.976. Question asked for it to one decimal place. Identify the second one. See if I round up or down. I'm rounding up, which gives me 33.6 degrees. So that's the end of the crossover sections. So if you are covering the foundation tier, please watch the remaining aspects of the foundation video. There are 2 more questions, question 27 and 28, that's on foundation, that's not crossover content, as well as all the questions that came before. And if you're on higher tier, please switch across to the other video for the remaining question 7 through to question 21 for this paper.